see. All right, starting in a second. Recording's going. It's up recording. Wait a little bit. Let's see, my mic seems to be going. Cool. Always have some weird lag. All right, let's open up the chat. There we go. Let's go stuff position. All right, if anyone's rewatching this, this is the setup process for a webinar. Relatively straightforward. It's another 5 minutes y'all don't see of me positioning my windows and notes and the chat, and then admitting y'all once everything looks like it's good to go without you having to see it. So if you were waiting in the waiting room for a few minutes, that's why. Good. All right. Can I read this? Yep. Read that. Yep. All right. Tissue. Yep. All right. Or waiting. Oh, that's weird. Right. Waiting room's there. The chat so I can see it better. That's probably easier. Participants. Only 3 waiting now, so I'm dip. All right. All right, let's let everyone in and test my audio. Ran out of tea before the webinar started. Not good. All right, whatever. Do my best to keep talking. All right. 1, 2, 3, 4. All right, we got 3 connected to audio. Cool. All right, all you have joined us early. Thank you. I'm going to ask that one of you real quickly jumps into the chat and lets me know if you can hear my audio. Hopefully you can. Otherwise, no one's going to do it anyway. So if one of you can hear me, it'd be great to know. Thank you. Always a quick check I got to do pretty straight off the bat. Cool. All right, I'm going to give it another minute or two for people to trickle in. I'm going to leave you on my browser screen. You should be seeing, and I always ask this question just in case, Google Chrome window with a single tab open on it that has anaconda.org up. Can someone just give me a quick yes or no? Make sure that's the screen that is sharing, because the green underline isn't really up around the shared screen. All right. Oops, there we go. All right, I just edited. Same screen still. We're on to, you're still seeing anaconda.org up? Awesome, thank you. Because that is my, you know, my display that's not my notes for cheating off of. So that's good to know. Cool. All right, it is 6 o'clock. I'm going to give another minute or two for y'all, just for people who are assuming it opens at 6 instead of slightly before 6. If anyone would like, before I introduce myself, which I will do once, just so I don't have to do it 6 to 8 times as people trickle in. This is one of my favorite webinars to give. For Byte Academy, I've given this a few times in various online or offline capacities, which I guess wasn't a webinar, but same idea. People come here specifically from all kinds of different backgrounds. If anyone specifically is here for any reason, obviously a background that requires no coding experience, but one second, I'm going to ask that y'all for now stay muted, just to keep things from getting too chaotic. But if anyone wants to use the chat, just say why you're here, what you're hoping to learn, what you're interested in particularly, feel free. I will address whatever I can over the course of the next 2 or so hours. If you don't want to, that's fine. But it will help me at least tailor or put some things from the webinar into slight context. Does anyone have any coding experience of any kind? VBA counts, MATLAB kind of counts, if you want to count it. Weird scripting background counts. Has anyone used Python before for work, for fun otherwise? School, studying data science, minimal experience, SQL. All right, a lot of people have minimal experience with SQL, Python, SAS. Again, MATLAB are similar analytical environments or languages. No coding experience, interested in data science. Python is a need to know if you're starting now as opposed to at some point when R was a little more popular. Everyone uses Python in your lab. You've learned some secondhand. It does rub off on people sometimes, but no training. One who's got Python experience, good to know. Just started learning. Python's pretty easy to pick up for y'all who've just started learning, so that's hopefully not going to be too bad. Cool. If you have Python experience, anyone here, hopefully you don't have too much like Pandas experience, because otherwise this is going to be pretty introductory to you. But we occasionally get people joining. I've had people join webinars that are experts in the intro webinars topic and stay the whole time and enjoy it anyway, so no pressure. Other thing to note, by the way, folks, I will be sending a follow-up email to this webinar that will include a link to a recording of said webinar, which means if you have to leave for any reason, if you disconnect, God forbid I disconnect, which shouldn't happen, but you never know. You miss something, I go kind of quickly, whatever, there will be a recording, probably a Dropbox link you can get afterwards. So feel free to follow up on that once you get the email. It should be pretty helpful to you, hopefully, if you feel like watching this afterwards. I will leave the Dropbox link or whatever up for at least like a few weeks afterwards. Assume that after that point, people who wanted the video have acquired it. But if after the fact you also want to get the video, I will also give you my email so you can contact me that way if you, for whatever reason, need to follow up. Otherwise, if you notice that periodically during the video, I will be looking up above my webcam, that is simply because my large monitor that has my notes and all the Zoom associated stuff on it is above my computer screen. Apologies that I can't look into the camera the whole time. It's just the way it is. Anyway, it's 6:05. I will buy the last few minutes for late attendees by introducing myself and the webinar and kind of what we're going to go over. There we go. There's at least one more joining. Awesome. All right, cool. So my name's Greg. I am one of the full stack instructors at Byte Academy. I primarily teach full stack development, although I have helped with our data science classes and data science students. I have some knowledge in that area, but not enough to really like full on teach the like harder concepts of data science. Apologies, I'm gonna keep admitting people to the room as I talk. But I at least know some of the stuff, and I'm pretty well acquainted with Pandas, Jupyter, and the basic analytical computing environment for Python. If you have interest in any of this stuff at all, please let me know after the workshop. I will point you to the correct place. But let's see. So about my background real quick, because some of you seem to be a little bit, not necessarily similar, but we all come from a similar place. I did not study computer science in college. I studied environmental science. I minored in economics and biology. I came to Python through something kind of like this, but in a self-taught capacity. I encountered Python for the first time as a scripting language for the ArcGIS mapping software, which is sort of an environmental science, environmental mapping type tool. Python is useful not only in its standalone environment for scripting and application development, but also for, as a scripting language. Some applications support, I think Excel may at some point in the future allegedly support Python for similar capabilities, but we'll see. And then I ended up liking it. I additionally kind of originally learned it for these sort of analytical capacities. Basic data analysis, basic plotting, charting, sort of browser-based calculation like we're going to be going through today, and then ended up pivoting more to the engineering side of things because I ended up really liking making engineering type stuff that worked and that had a more visual, exciting usability payoff than analysis, which isn't to say analysis isn't fun. I still use a lot of this stuff from my day-to-day anyway. But the engineering side of things just like kind of grabbed me and popped for me. So I kind of pivoted to the Python, JavaScript kind of full stack side of things. Obviously, that's what I ended up teaching at Byte Academy. These are all useful skills for anyone engineering, not engineering, kind of whatever you end up wanting to do with it. If anyone is watching on an external monitor or a different screen, by the way, if you want to, you can theoretically code along to today's webinar. I usually take it a little bit quick just so we can get through as many concepts as possible with the video and the code. I will send you a link to download as reference afterwards. Because again, this workshop has no Python knowledge required. I will try to get through the basics of Python, or at least what we need for today, as fast but easily to understand as possible. If you're interested in the computer science theory of this stuff, that's kind of a thing to look up as a next step on your own, because we'll go through a very functional utilitarian version of things. Otherwise, as somebody who speaks relatively quickly, if I speak too quickly or you miss something at some point during the webinar, please throw it into the chat. It is fine. My students tell me all the time that I talk too fast, or when I talk too fast, not all the time that I do. I'm used to it. Just let me know. I will reiterate or solve a question or, repeat something if you need it. Just let me know as soon as possible so you're not lost. All right? Yes, I will be sharing a recording. If you joined, feel free to ask questions I might have mentioned. I will answer most of them as efficiently as possible. I will be sharing a recording after the webinar for whatever if we disconnect. I can't promise when I will send that to you because Zoom takes a second to compress the video after a webinar, and then they send me an email when it's done, which may take a second to send and get here. But once I have it, I will put a link in a meetup email, send it to y'all through whatever email you used to register for meetup. If you don't get it or it goes to spam or you lose it or whatever, again, I will give you all my email after the webinar. You can always follow up later. I can resend you the link or any other material you want as well. I'll probably need to send you a Dropbox or a Google Drive link for the code as well, because Meetup's UI doesn't really let me send you guys attachments very easily. I need to usually do links instead. If something doesn't work, please let me know. I want this to be as usable for you after the fact as possible. I will also send you guys a link to the data that I used today. Being that we're going to be going through some basic data analysis and cleaning, I will make sure to send you the exact data set, the exact CSVs I use, so that you can go through and run the exact code I write today as I did, either along with the video or on your own, or to kind of mess around with it a little bit more on your own. But if you don't get any of those things, or the link doesn't work for whatever reason, please follow up with me as soon as possible. It will mean that everyone else has the same problem and just didn't email me. All right. In the meantime, we got a few other late joins. All right, to reiterate for the people who just joined, I will be sending a video because I've gotten that question a few times, either public or privately, after the webinar, so no worries. Otherwise, it's 6:11. So I'm going to go through a quick introduction here. Has anyone here, I'm assuming some of you have because of the backgrounds you gave me, has anyone here heard of a Jupyter Notebook? Via the chat.
Yes.
There's at least 1, 2, 3. All right, they're pouring in, yeah. So I imagine most of you have, I mean, technically reading about the name on Meetup as I wrote it doesn't necessarily count, but yeah, most of you probably here for a reason, you've heard of it, cool. So really quickly, I'm gonna show you, if you use code, if you've written code, if you're used to code in your command line and installing things, running things from your command line, that's great. That's how I'm gonna run mine on my own later. If you are not, I'm gonna jump to this nice placeholder screen I've had up this entire 15 minutes or so, from Anaconda.org. Anaconda is basically an analytical computing distribution of a lot of packages, a lot of software packages and environments. You can download it for free from this link, Anaconda.org. If you like, it gives you a program, a clickable GUI you can use to launch a notebook and to do a lot of other things that would require your terminal or writing code instead, which obviously I'm comfortable doing, but many people aren't. To prevent that being a barrier of entry for you guys, I'm gonna just show you this link real quickly. You can download Anaconda for your specific operating system. It will have Python included with it. It will have all the libraries we will use today for Python included with it. And you should be able to launch a Jupyter Notebook from the Anaconda GUI with just a click or two. And I will send you guys at the end of today some documentation on how to open a Jupyter Notebook from Anaconda, the GUI, just a quick link from their docs. Afterwards so that you guys can do that. I will start up the Jupyter Notebook environment again from my command line. I don't personally use Anaconda. I handle my own installations and everything relatively on my own. Does anyone know, has anyone used a Jupyter Notebook before or tried to? All right, we got at least one no. All right, cool. I'm assuming some of you probably have. We're going to go through at least launching one and a quick overview of it and what it does. But generally speaking, it's as simple as downloading the Anaconda application, clicking Launch Notebook, and it will open up a, not a notebook, but a notebook server, which will look something like just launch one and then close, bring the tab over here. What does it say? April 29th. So when you launch it, it will take a second and it will open up a notebook, which is actually an interactive file browser, which looks something like this. All right. And if you use Anaconda, it'll be a little bit different. So if you use Anaconda, it's going to look a little bit different. It'll open to some other directory on your computer. Mine opened up to a blank directory I just created. The notebook is now right here, which is all fine and good, but I'm going to first click New Python 3. If you see to create a new notebook, you just click the New tab. You click on the language you want. I only have Python installed. There's a few other plugins and languages that notebooks run as well. It's not just a Python environment. There's other stuff you can do with it as well. But ultimately, it opens up the notebook, which will look something like this, which may, if you're used to it, or used to an Excel-based environment or some other spreadsheet software, depending on your operating system or where you work, you may see, or you may be used to something like this, right? This is a cell-based environment where you can write and run code. It just isn't the same two-dimensional like data analysis environment. All right, it looks, unlike most places you might write or run code, it looks relatively straightforward, more like a normal application we might use. All right, we've got, file, edit, view, insert tabs up here, right? File does things like save, download as, whatever. Admit one more person, there we go. But ultimately, this is the full environment, all right? And there's a bunch of different cell types you can create too. Markdown, headings, things for writing and annotating your code as well. I'm gonna keep this on code the whole time because today's really about writing and using code, all right, in the notebook. Annotating it with Markdown is like a nice to have, but we're not gonna do that today. All right, if you haven't seen Python before, we're gonna go through a quick intro to Python and just basic kind of writing code and getting an output, all right? This isn't gonna be a huge overview of the language. If you would like that, I will be running a workshop a week from today that is a similar overview of Python specifically. It'll do more of the same concepts, but more in depth. But generally speaking, right, this is an environment to write and run code. And when I say code, I just mean expressions of any kind, right, that happen to be in Python syntax, right? So if I write an expression like this, right, technically this is a Python expression. When the Python interpreter sees this, resolves it, it gets it down to its final value, which is just gonna be the number 4, all right? And if you notice, right, for every cell you have an input, which is kind of the code or expression you write, and then you get below it, when you run it, an output. All right, and there's a bunch of ways you can do that. There's this run button at the top. Run will again make the interpreter kind of read and figure out what this says, do what it says, and then give you its output. All right, so this ends up resolving to 4. The hotkey I used was instead the shift key and my enter or return key. All right, I'm using a Mac, so it's the return key. But for anyone who wants, I will also annotate at least some of this notebook so you have some notes. All right, so you can type shift plus enter to on each cell, which ends up being much faster. As you can see, this is a comment. So the # in Python is a 1-line comment. It basically tells the interpreter to ignore the entirety of this cell. All right, or everything on this line after it. If I indented with my return key, but not shift, I can keep writing something down here. And if you can see, right, this is not teal. This is not commented out, right? This is actually going to run. All right, we get an output here of 13. As you might guess, or might have guessed from this, Python supports both, supports most of our normal mathematical operators we might remember, right? So we have addition, right? We can use subtraction instead, right? 3 minus 7 gives us -4. There's also division, which will, give us a very long decimal. Multiplication is an asterisk. And those are the basic operations we'll probably get through today. We might see one or two other ones that I will touch when we get there, all right? As we can see though, right, this is a relatively straightforward way we can write simple math, get simple mathematical outputs. Even if you don't do Python, you can use this as a relatively simple, straightforward calculator. But to take things a step further, at the code side of things, we can also look at what's called assignment, which is basically, right, taking some kind of name that we create on our own. Here I just used A, right, the letter A, and assigning that using the equals sign. Assigning that to the output of a value, right? So if I say A equals 9, we get no output, right? But this ultimately means that I have now stored in the name A the output of this expression to the right of it, all right? So if I just type in A, I'll get back 9. If I type in A plus 6, I'll get 15. And this is a way with code that we can kind of reuse or create a name and then keep binding things to it, being able to reference the value with a name we create that we can kind of throw around in our code. And we'll see that a little bit later. But it's important to remember this concept in a little bit. All right, so far we've seen really two different data types. And when I say data type, I just mean whatever I write that is not a variable, right, is treated by Python as a specific like genre of object, right? These are all numbers, right? We think of these as numbers. Technically, we've seen two types already. We've seen the integer, which just like elementary or middle school math, right, is a number that has no decimal and nothing after the decimal. So that's things like 3, 4, 100, right, but not 3.6. All right, so these are all integers. When I did division, we got a second type, which is called a float or a floating point number. All right, and so this is, by Python's reasoning, is a different type, but it will handle them as almost the same. All right, so if I use Python's built-in type function, which will take an input or an expression and then return to us exactly the type that its output is. So if I say type 7, I will get back int, right? For integer, if I get 7.0, it'll give me back type float. All right, so you've seen these two types thus far, right? People think of computing or coding, they think, you know, oh, there's a lot of math involved. There's actually frequently not too much math involved depending on what you're doing. So there's a lot of other data types that you might have to deal with. Today, with some you know, data that I got off of the internet that we're going to deal with, we're going to have to deal with a few other types too. The other most important one you'll find, at least in 1 or 2 dimensional data, is usually going to be the string, which looks like this. String is basically what we think of as text, right? It's a sequence of characters, including punctuation characters, including lowercase and uppercase letters, also including the space as just a character. Behind the scenes, your computer sees these all as just different values anyway, but including punctuation, including pretty much any character you can think of that will render. And in Python, these are enclosed within either double quotes or single quotes, and both are usable for a string. I usually recommend, I personally use double quotes mostly because it's a little bit easier to see than single quotes, a little bit more aggressive on the eye. So it's easier to point them out quickly. Ultimately, most people will just choose one that they prefer and use it consistently, or choose whatever they are told to use if there's someone else who they're writing the code for, and then use that. So I'll just string with a number in it. I'll end it with a 9, right? Again, this looks like 9. This is technically just another string character. Of note, right? This is now an important difference that is not always apparent to people. In terms of a string versus an integer, right? This here is still a string. It's enclosed with quotes, even though it is a numerical character, right? This is the string version or the character 9 and not the mathematical value of 9, all right? Which can throw people for a loop, especially dealing with data, right? If they're reading data and it comes out encoded as a string instead of something a little bit more useful, if they think it's like, oh, this is a numeric column, of course, and it turns out to not be. Usually that's why. So types will come up and be kind of important for us later. Otherwise, Python is relatively straightforward with how it deals with integers and floats. It can treat integers and floats as largely the same. For example, if we have 8 plus 8.0, right, this will give us 16.0. It'll give us a float, but it does the math the same way as if they were both integers or both floats. It takes them both as values. The math works pretty much the same both ways. Python's known for having a big built-in library of a lot of very useful code, right? So we have some functions like, for example, I'll just throw in the round function because today we're going to be doing a decent amount of basic math, some string manipulation, but a lot of basic math. So we have some things like, there's another one. All right, so we have some things like the round function, which is built in, and I will just throw quickly in an expression. The way this function works is it takes in an expression and then a number of decimal places. I'll just say 3. And it'll perform this calculation and then give us the output, but rounded to this number of places, which can be very useful because otherwise, right, 8 divided by 3 is going to really go on almost forever. So hopefully everyone is still with me. Nothing we've done thus far is too groundbreaking. If you joined late, which a few of you did, all I did was go to briefly show people anaconda.org, where you can download the computing environment to create a Jupyter Notebook server, this guy right here. Once you have that going, you can just create a new notebook. I'll give it a name today. Workshop, April 29th, which I believe, yeah, is today's date. And then you're pretty much good to go. It runs in your computer's memory. It will, as you ask it to, run your code, give you your outputs, do what you ask it to. Real quickly, we will be at the not just basic Python, but more interesting Pandas side of things in a second. But the next thing we're going to quickly do is just define what's called a function, all right? When I say function, think of it for now as just a reusable portion of code, all right? If I wanted to add numbers and stuff together all the time, probably isn't the best idea to always rewrite those lines of code to do what I want. I could write them once, give them a name, call them whenever I need to, and that's really what I'm going to do. So I'm going to define a function. I'm just going to call it add1 for now. In Python, to define a function, we use the def keyword, and then a name. I just called it add_1. And then that's followed by parentheses, which can either be blank, or in this case, I'm going to give it an argument. I'm going to call it x for now. And this is, you can think of it like a name for the input we will get when we use our function later. And then finally, return is what the function will give us back after it performs a computation. All right, so if I did this, this would really be a function that takes in an input, gives us back the exact same input. So for example, if I did, called add1 passed in 5, it would give me back 5. All right. Ooh. So in the chat, let me just pull this up. There you go. Somebody just threw this link in the chat. If you would like to, you can try a Jupyter Notebook. It looks like online without downloading it. If you visit this link from the chat, Jupyter with a Y, Jupyter.org/try. You can choose your language, probably this one, top left, and then you should be good to go. Thank you, whatever hero posted that in the chat, because many of you don't have full names. Ultimately, my add one function here is going to instead return me x plus 1. So it will take in my input x. It will return me x with 1 added to it, all right? Which implies, obviously, that x, our input, is going to be a number whenever we use it. I had to run this cell. I got no output, but what running it did was just read this function into memory so that in the future, I can use it. It basically gives me access to it for the rest of my notebook and the rest of my code. So now if I type in add 1, pass in like 9, I'll get as an output 10. All right. If I pass in, however, 9, and I try to run it with 9, I'm going to get a Python error. And this is a good time to introduce what a Python error looks like. Which looks like this, all right? If you haven't really dealt with code before and you plan on trying some of this stuff out on your own, perfectly fine. Just know that you're going to encounter these sometimes. There's nothing wrong with errors. A lot of students I teach especially, but anyone getting started with code gets frustrated. They think that error messages are telling them that they're doing something wrong or bad, or telling them that they're bad at code or something, right? You're not. It's not what it's saying. It's just helping you figure out where your code is having an issue, what's wrong with it, right? Here I got a type error. It's pretty self-explanatory, hopefully. It points to the line, right, add 1, 9, and it points to me where in this function that I called it's actually wrong, right? It's here, and it says can only concatenate string. What it's really telling me is, Greg, you have a number and a string. String plus number doesn't make sense to me. String plus string does. I'll just add them together, like concatenate them. Number plus number does as well, but I cannot add these two types that are not similar together. So I could add error handling, make my function sometimes handle for that. I'm not going to right now, but it's worth showing to y'all just so you know what these Python error messages look like. All right. If you try this code, get any errors, super confused, again, drop me a line or something. It's fine. It is my job and happens all the time. Perfectly happy to answer questions, at least between certain hours of 10 to 5. But I am just copying a bunch of CSVs real quickly. Copy. Where is it? And I'm going to paste them into my one Jupyter Notebook server, just so that I have all of these ready to go. Or actually, I'll do it from my other window you guys can't see, just to make it easier. Anybody put off by all the Python stuff we've gone through before I jump to anything else? Hopefully not. But it would be good to know if you otherwise, or not at all. That's a great sign. All right, cool. This is relatively introductory stuff. Obviously, it can go a lot deeper, but it should, for at least now, hopefully be relatively self-explanatory. There we go. Paste 23 items. I did just paste 23 CSV files. I'll explain to you what they are in a little bit. But yeah, so far this has been relatively simple, right? The most important thing is that I will reference what I've done so far a few times later in the workshop. It's important for you to understand at least these core concepts, so that if I have to make a function, cool, at some point, you'll kind of be able to follow. The next thing I want to look at really quickly is to just quickly look at one other Python type, which is called a list. A list is a collection of many elements, an ordered collection, which means it has a start, it has a finish, it has a first and a last. You can access its elements positionally if you so choose. I'm going to start with r_list equals, and then 2 square brackets. If you've noticed, I have been using what is called snake case for all of my variable names, which is what Python tries to use as a convention for variable and function names, which is just lowercase letters with any words or phrases separated by underscores. It's the Python way to do things. No, your code will not break if you don't do it. if you care, it's a good practice to get into to kind of write your code the way most Python code is written, if you're curious at pursuing this for a little bit. Always good to get into good casing and writing conventions if possible. So I have this list. It has no elements. I could instead add elements to it. I'll just add 1, 2, 3, 4. Lists are what is called heterogeneous, meaning that they can have pretty much any collection of types in them at once. They don't care. So I could add, 4 integers, a floating point number, and a string to my list. It works fine. I could add another list to my list as well. Right, I'll give us a little bit of space here so we can see. Right, that also works. Python will, again, not care about that either. It will assume, which is kind of a Python convention, that pretty much, someone just posted in the chat, Google Colab is good for Python also. I've used it sparingly, but it's a relatively good browser-based way you can get started with code. There's another site, cloud site as well, repl.it, R-E-P-L, which is a decent environment for creating and also being able to save code in the cloud if you are curious, repl.it. I will include that in my email. This is more from me than y'all, but if you want to write it down, feel free. But if you create an account, it lets you save code in the cloud, which is nice. The only issue is there's occasionally synchronicity issues between you and their servers. So you have to refresh your page every 15 to 20 minutes if you're not using it often. But the last important concept to get through is what's called iteration, which you can think of as a way to progressively step through a collection of elements. All right, so here we've got this list of elements. In Python, the most simple way to iterate through this is to just step through it element by element and do something. All right, so I'm just going to say for I in our list, and hopefully this reads a little bit like English and is relatively easy to follow. Right, for I is just a placeholder name I've given to each element. This is ultimately for each element in our underscore list, right? It's the list that I created. And then a colon. And if you see, my line break is followed by an indent. Just like when I define my function, Python uses an indent of 4 spaces to really denote some sense of belonging. All right, it really says this bit of code is attached or belongs somehow to the unindented code above it. All right, so what this means is for each element, I'm going to run this indented code. For now, I'm just going to use the print function, print I. What print does in Python, it takes its argument, shows it to you as output. The Jupyter Notebook will show you return values of most expressions anyway. If I want to show a lot of values though, print is a helpful way I can do that. All right, so if I run this cell, it will print each item on a new line, right? We get 1, 2, 3, 4, the float 5.0, a string, and then our other list. All right, this is the concept of iteration. It will matter at some point later when we have to, go through our data element by element, row by row, do some things iteratively for a large number of elements. All right, so now that we've been through most of this code, right, and just to get actually one more iteration example, let's say for I in our list. I'll just change this to numbers for now, right? We can combine all these things together. To note, in a Jupyter Notebook, it doesn't actually run top to bottom. How are those sites more advantageous than using Sublime Text? They're not. If you're not used to using an editor, they're just faster and require less learning. But if you use an editor already, you are good. With the caveat that Jupyter Notebooks theoretically run in editors. They don't do as well in editors as to your browser. So this is also its own decent environment. No problem. If I see stuff pop up in the chat, I will answer it. I just can't guarantee I'll see all of it. Anyway, as I was saying, Jupyter Notebooks don't always run top to bottom. They technically run in the order in which you run your cells, which matters because I just reran our declaration here of our list. And what that actually did is overwrote the variable name our underscore list in memory. So I kind of lost our old list. If I rerun this cell now, it will only give me the new values, which is nice. Most code has to run the entirety from top to bottom to do anything. Jupyter Notebooks don't. They preserve everything you've run as it was when you ran it. The only issue is that if you run your cells out of order at any point, you may confuse yourself by starting something, not running something later, kind of confusing yourself through all of that. But if I say for I in our list, right, and I create a variable up here called total, which is equal to 0, and I use plus equals. Plus equals is a shorter version in Python of total equals total plus I, right? So I could instead say like total plus equals I. It's just shorter and cleaner. I will add them both for you, just so you can see both, and I will comment this out for now. And then at the bottom here, I print total, right? We're going to get 15.0, right? So you will actually go through this, right? Total is equal to 0. So as we go through our list, we say for I, right? First time I is 1. Total plus equals 1, right? So total equals 0 plus 1. Total is 1, right? Next element, total is, 1 plus 2. All right, 3. Total is 3 plus 3. All right, 6. Total is 6 plus 4, right? 10. And then 5.0, we get 15. So we can use iteration like this to our advantage to write code that will do something, new attendee, many times as we kind of step through something, all right? For the people who joined us decent amount later, you will get a recording, so don't worry too much if you miss things, all right? So we've got this. Anyway, I am going to jump now from the basic Python side of things, and I am going to bring into memory our 3 libraries we're going to import today, and we will use at least 2 of the 3, if not all 3 today explicitly. One of them is a dependency of the other 2 though anyway. So in Python, there are a ton of third-party libraries made by fine developer heroes who decide to write code for you to use for free rather than you writing it yourself, which is nice and why Python is considered an extremely efficient language for development and computing, because it's very easy to use very highly vetted, highly rated libraries for things like data analysis, and kind of use their own functionality to get stuff done faster than write all of the code on your own from scratch, which is great. So I'm gonna use the import keyword for that. So I'm gonna import pandas. And what this does, it took a second, but the import keyword basically takes a name, right? So the library is called pandas, and we'll read it into memory. Alternatively, I use the as operator in Python to basically assign it to a slightly shorter and easier to use name. So instead of calling it pandas, I can just type PD, access anything from the library instead with that slightly shorter interface. Pandas isn't that long a word. Abbreviating it to PD can be a little easier. It's also just convention. So I'm going to add 2 other things. I'm going to import numpy as np, and I'm going to import Matplotlib pyplot as plt. Pandas, quick intro, if you didn't look stuff up for the webinar specifically. Pandas is basically Python's go-to 1- and 2-dimensional data processing library. NumPy is a 1- or multi-dimensional data processing library and mathematical computing library. Pandas is based around a decent part of it. It has a lot of higher order complex mathematical functions. If you're into scientific computing or higher level calculations in math, it's a good thing to learn. Both are extremely deep. You can use either one basically like its own language. There's a ton of functionality in there. We will barely scratch the surface today. For more practical concerns, their documentation is good. I will obviously add links to them and their library documentation later as well, just so you guys have that for after the webinar. All right. Matplotlib is a charting library. It will create very quick, simple charts and graphs for us, so that we can basically take our data, visualize quick snapshots of it in 5 lines of code. We'll do that towards the end once we have some chartable data to look at, because it can be very useful for most people. All right. So the whole utility of why we're kind of here today is for some analytical functions, right? We want to take some data, we want to load it into Python, let Python help us do some analysis, clean it up, convert it to something more useful. And then ultimately we're going to look at a chart or two from it just to show how easy that is. That will honestly take like 2 or 3 minutes to at least get an output of a chart and then tweak it a little bit. But not to be all like this stuff isn't hard. I wish it were harder, but I wouldn't be able to teach this workshop if it was too hard to do. So we're going to start off with something simple, right? We're going to ultimately read a CSV. And if anyone has not explicitly dealt with CSV files, think Excel, right? Or any spreadsheet software. CSV just stands for comma separated values. It is literally, I added a ton of CSVs right here, 20 something. It looks like a text file. I'll just click one of them, view it raw. Cool, right? I'm using some free data that I could find on the internet. It's sports data. You could extrapolate this to be anything from finance to inventories for retail to payroll data to anything that you can think of that has rows and columns, right? Because what ultimately matters is that it's made up of integers, floats, and strings. And we'll do some analysis of all of these. But ultimately, it's the text file, right? This text file of, right, a header and a bunch of rows that are all formatted the same way. All right, so our header of the data is just a bunch of strings. And the way we know when a column ends is just a comma. All right, so we have columns between, I'm going to ask that you all keep yourselves on mute and use the chat if you can't hear me. All right, one quick second. Is my audio back? Awesome. Cool. Jump on that as soon as possible if it happens. In and out. All right. Give me one quick second. All right. I turned the audio out on purpose for a second, so no worries there. Yeah, I just restarted my audio and video. It should settle in a second. Sometimes in calls, Zoom has slight issues with bandwidth. Usually it sorts itself out after a minute or so. Anyway, I will take it slower for a minute or so just to make sure, but generally speaking, right, this is just a text file made up of strings or integers or whatever, separated by columns. And the way you delineate a column, right, is just a comma. So all of these columns are just commas. The way you separate rows is with a new line, right? So we indent from here to the next row. That's really what a row means, all right? So a CSV is just a specifically formatted text file. Think of it like Excel or something like that. The only difference is that with Excel, it is in fact a slightly different, I think, like XML-like file. We'll get there in a second. I assume many of you, oh shit. All right. I assume many of you use Excel. Just a guess. in your day-to-day jobs or lives or whatever. Is my audio back? Nobody has said it's back, even though someone said it was gone again. All right, cool. I assume many of you use Excel in your day-to-day lives or some spreadsheet software. CSV is basically the simplest type of spreadsheet, all right? I'll be using that today because it's kind of program independent. But the first thing I'm gonna do here then is just open up a CSV file. All right, so I'm going to start using the Pandas library for that. So I'm going to jump down here and I am going to use our first Pandas library function. All right. So in Pandas, or to access anything from a library, right? The simple way to do this is to just use the library name followed by a dot. And then you have access to any of the functions or methods created in the library. So I'm going to use pd.read_csv and pass it in a file name. And this is basically a library function that will look into, look on my hard drive, look into the same directory as this Jupyter Notebook, and it will try to say, is there a file with this name? If there is, we'll try to open it up into a Pandas data structure, right? So I'm going to give it the name 2010.csv, which is just one of the CSVs I have there. Run that cell, all right? As you can see, once there's a number and not an asterisk, it finished processing. So we'll look at this real quick, right? And this is kind of how the Pandas library will open up a CSV for us. Really, it will show us this sort of two-dimensional object, right? We've got our headers up here. We've got all of our rows here from 0 all the way through to 319. All right. This is in Pandas what's called a data frame, which is how it represents two-dimensional data. All right. It technically, use the plus sign, create a new cell, move it up a little bit. There we go. Technically, there is also a Pandas data type that is like a list, but optimized so it computes a little bit faster, called a series. And I'll just create one real quickly so you can see it, right? And the difference with a Python list, it has a bunch of its own specific methods you can do to it that make it a little bit faster, more optimal ultimately. All right, this is pd.series, cool. And so if you look at this, right, we'll notice that unlike a Python list, our series has, I'll add an extra number that's not in order. There we go. There's a few differences, right? We get all of our values here, but we also get the index position, right, or order basically of each of these elements. You can think of it like in a spreadsheet, right? On that left side, you have your 1 through number of rows, right? Usually indicated. Some integer that gives you a row number, same idea, right? It's the element's number from the start. The only difference is that almost always with code, these start at 0. It's just the way it tends to be. So you have elements 0 through 5, right? The integer 1 through the integer 900. And it also assigns a data type to your series, which is really a way it can quickly try to reference what exists in here to optimize how it processes your data. All right, so it says these are all integers, so it gives us this integer data type. All right, once we have these integers, we're basically good to go. Now that we have these, we can think of now, if we go back to the data frame, right? Data frame is a similar way we can represent two-dimensional data. But the way Pandas thinks of it is it's really a bunch of series objects, with the series being each column, all right? Each of which probably has its own data type. If you think about it, right, most spreadsheets, each column represents the same thing. So it's almost always going to be the same data type. We'll actually get to these guys in a little bit. And so we can start looking at our data, right, and trying to process it, analyze it, right? And also, unfortunately, the most important thing in most data processing, we can clean it up, which is not fun in any way. And I wish this workshop could be a little bit more fun at this point. But the thing is, most data has to be cleaned before you can do stuff with it. And like 80% of most data work, or data pipeline work at least, is cleaning data so that it goes from whatever crappy version it started out in into something much more useful. Same thing here, right? So at first glance, it looks like, right, I have this column, and I'm going to pretend I've never seen this data before, even though I've used the same data a bunch of times, so much that I actually don't have a new CSV for the current year of football data. I last updated this in, I think, last May. But we have two columns that are redundant, right? The only difference is that one starts at 0, like code thinks, and one starts at 1, like people think. And these are otherwise both an index column, which is kind of unnecessary to have. Pandas will always add this column for you. Unless you tell it not to, it will almost always add you a random index just to give you a bunch of numbers. Otherwise, we have this column, which is called unnamed :1, which is a placeholder Pandas uses for a column that doesn't have a name coming in. If you look at our original data right here, we actually have 2 commas next to each other. This means that our second column actually had no original name, which is unfortunate. So we're gonna have to deal with that probably. The rest of the data, to me, looks pretty good. These names have some stuff on the end that has no real reference. I believe this is actually a way the site I got it from stores what each player's unique like URL ID is. So if you go to sportsreference.com/this, you'll get this player's data. But lastly, there's a few things that happen relatively often in data, right? And I'm looking at this percentage, which looks like it's a float, but if you think about it, definitely isn't a float, right? This seems like it's a float. There's a percentage sign in there, so it obviously can't be treated as a number. This is going to be a string. You might have to change that. All right, and otherwise we can perform some basic analysis of the text and numerical columns. Additionally, we have these values here, right, which look like no data type I've seen really, and that's because those are a placeholder that we'll get to in a second. All right, so we just took a quick snapshot of our data. We can kind of move on and try to do something to it. Really quickly, I'm going to use this method of the data frame. So when I said method, right, if you see before, we can use a dot to call functions from the library, but we can also use a dot here to call functions that are related to and a part of a data type. And so, believe it or not, in Python, pretty much every data type has a method. Strings have specific methods, lists have specific methods, data frames have specific functions that work on the data frame, and we call these methods in Python. The head method of the data frame is simple. It will just give us the first however many rows I give it of our data instead of its normal output, which is like 5, an ellipsis, and then another 5. All right, so if I need 4, I can do that. If I want to only see 2, because I think that seeing 2 different rows is good enough for me for now, I can do that, take up less space. All right, so this gives me a quick snapshot of my data. The alternative is df.tail, which will show you 2 rows from the end of your data, right? Last row and the one before it. They're pretty much synonymous with each other depending on the data you use or what you're looking at. If it's time series and you care about recent versus old data, this is when these 2 might get a little bit more useful. So if we keep looking at this, we can also use Python's built-in length method, right? len, which will take in a thing, an iterable of a number of elements, think a list, a string technically, right, number of characters, and it will tell you how many elements exist in that, and it works with a data frame. So the length of our data frame is going to be how many entries it has, right? We can see that here, but we have 320 different rows. All right, so we can say, cool. This is the size of our data. 320 is not too much. It's a little much to do with just your eyes to do anything to. This obviously can scale to, you know, thousands if we need to, right? Another audio out again. All right. All right, my audio should be back, I would imagine. Cool. I always need that second confirmation, otherwise I don't know. So now that we have 320, right, it's not a lot, but it's enough. You could extrapolate this to thousands if you want to. Another CSV I have in here that you guys are going to free to use after has, I think, you know, 8,000 or something rows, which is enough that you can't deal with it really in like Excel or something easily, right? If you opened it in Excel, it would at least get very slow. So now that we have our length right number of rows, we can continue on. And I'm going to use a just very quick function called describe that will just give us a quick statistical snapshot of our data frame. All right. And this is just going to be quick things, right? Number of values in each row, which is very relevant. Average value, standard deviation, right? Minimum value, quartiles, and then our max. All right. And this snapshot can be important. For example, if I look at count, which is just unique values, unfortunately, it's a float by default with a lot of zeros. We can see that these don't all have 320 values, which will be an issue, right? And almost all data sets have missing data, right? These columns have almost 100 missing data points, which could be an issue, especially when using code. Because if you use Python and try to do something to every element in a column, manipulate it, create some aggregate or something, and you have missing data, you're obviously just going to get an error. All right, so this can be extremely important to look at quickly. Otherwise, these could be useful or not, depending on what you're looking at. You know, some of these, like age, obviously it makes sense to look at the mean maybe, but otherwise, you know, depending on what your data represents, these may or may not be as meaningful to you. So our next data type that I'm going to look at then is actually this weird data type here, NaN, which actually stands for not a number, which exists in more than just Python. It's a concept that exists across languages. It exists at least also in JavaScript. It's really used to fill in data that doesn't exist, that would just be blank, to help our calculations still work. Does anybody who has not used Python before want to guess as to what type NaN is? Well, I type it out. All right, nobody in the chat wants to guess. All right, then I will just run this line for us instead. There we go, we got one, string. So string's a fair guess, right? We got an N, an A, and an N. It looks like it's definitely a string. The cool thing about NaN, as opposed to like this, so it's not actually a string, Joshua, nice try. I did that on purpose, right? It is a float, which is weird. Obviously, it's a very weird idea. But the whole point here is that np.nan, or technically not a number, is a placeholder that will allow you to replace missing data with something that behaves like a number, so that many calculations will not be messed up. Some still will. It doesn't work perfectly. But you can fill your data in with kind of a valueless number, which is a weird concept, but can end up being very useful. All right, so it, depending on what you're doing, can be a great way to fill in your data. As we saw at some point up here, there were a bunch of NaNs in my data already. It's how Pandas by default will represent most missing data. Real quickly, our data frame has a nice built-in method we can use to check if any data is missing. df.isNa, right? The issue is that by default, this gives us back a copy of our data frame with a Boolean value, Boolean being another type in Python that is just true or false, and that's it, corresponding to whether the data is missing. And while I do see 10 different values of true here, this to me is actually completely useless, right? Because I can't go through 28 columns and 320 rows to check every single value to see if it is in fact the string, or not the string, the Boolean value true or false. I'll definitely at least miss most of them, if not give up partway through and never use pandas again. There's a built-in method we can use instead, any, which will actually check all of these outputs to check if any one per column is true. So any is just a quick sort of iterative way we can say, are any of these in this collection of elements true? And we get back a nice readout of all these columns, and then a Boolean value of if each of these columns has any missing data. And we see that 1, 2, 3, 4, 5, 6, 10 of them have missing values. All right, so 10 of our columns are a little bit messed up, not perfect. We can kind of take this and move forward with it, at least knowing that some of our data is messed up. All right, which is why I choose this same data set every time. So once we have that, there's a lot of different methods we could use to address this issue. For now, I'm going to use this quick function called fill_na. What this does basically, I'll start here, is it's a data frame method that will take whatever you give it as an argument and fill or replace any missing data with whatever your argument is. And for our purposes, just because I know pretty much everything that has missing values is numerical, or will be numerical in the future, I am in fact going to give us 0 as our filler value, and assume that for our purposes, the absence of data is the same as 0, right? A numerical way we can represent nothing, all right? So if you see this comes back with where we had the missing data, just zeros, all right, which for my purposes is fine. Not perfect, right? I made an important decision here, for example, to replace a text column with also a 0, which could mess me up later. We could do this per column instead, right? I honestly just in 2 hours don't have enough time to do it by column. All right, so now we have this. So we can kind of move forward, and I will rerun this now that I've manipulated my data frame, right? And as we can see, nothing changed, which is important to know. Most of these data frame methods in the Pandas library actually end up spitting you back a copy of your data by default, which is important. We didn't manipulate our data frame yet. We just got back a snapshot. The reason that we do that is actually because this is a sort of high stakes operation, right? I don't want to accidentally type in the wrong value, hit enter, mess up my whole data set. Here I'm going to reassign this now so that it will change, but it's important now to understand that this being code, right? Python's not going to ask you, are you sure, right? Do you want to overwrite a bunch of data with a new value? It will just do it. All right, now we can see that we now have no missing values. Cool. So actually, one second. Much better. All right, cool. So I filled in a bunch of values, which isn't super exciting, but is unfortunately necessary. We can continue on a little bit, right? We can start with looking at, all right, let's take a quick value from our data frame or a quick column, right, and look at its values. So there's a few ways we can do this. We can use brackets, and after our df variable name, right, that points to our data frame, we can give it a column name and a string, and it should return us that column. So I'm just going to go with tm for now, right? And it will just give me back the series associated with that column. All right, so I got basically like a list of 320 values. All right, of basically strings. All right, this is helpful, but obviously not too helpful. I'm going to just look at the unique values, right? And this unique method will literally return us the set There we go. All right, so to recap, I can use this bracket syntax quickly to access just a column, right? And then the unique method, instead of getting me back just this stuff, is going to get me back only the unique values or the set of values in this column. So I should go from 320 to hopefully, yeah, like some of these are redundant. So I should get back this, right? This is all of the values in this column that actually appear to be unique, right? That, you know, one occurrence of each element, basically. All right. So this is a little bit more useful, right? It won't tell me distribution or, you know, how many of each, but it will tell me just what they are so I can kind of move forward accordingly. There is another syntax we can use for this instead. You can use a dot, like it's an attribute, so df.team. Works the same way. The issue with this syntax is generally that if you have a column, such as this computer generated one, right? It has a space in it. This space is going to mess up the way Python reads this, all right? So it's usually easier to use the bracket syntax if you need to, unless you're going to first rename your columns. That makes sense to you guys, right? Because now we're treating this as the end of an expression and an integer and then a dot. And this will give us, you know, like some garbage invalid syntax error, right? This will work, although this being names, I don't really need to run it because the names should all be unique here. And we get back it doesn't give me a length, but I'm going to assume it is 320 elements. Whoops. Yeah. All right, but if your columns aren't perfect, use the strings just to be sure, especially if you didn't write all the data on your own perfectly. All right. Anyway, to continue on, right, we can start trying to change or aggregate some of our data. All right, and I'm going to quickly, let's see, look through our data. I'm going to move this column, I'm going to move this down towards the bottom. You can use the up and down arrows to move cells around freely. So I'm going to move this, whoops. Cool. Just so we can see our data frame, right? And I'm going to sort this. And if you look, I just hit my tab key. You can technically, if you forget the name of a method, if you're partway there and you're not sure, if you think you know what it's called, you can hit tab twice and your Jupyter Notebook will pop you up a helpful autocomplete. So now I get both data frame methods that start with sort underscore. All right, so I get sort values. And sort values can take a few arguments. All right, so I'm just going to give it by equals. This is how we sort. I'm going to just give it a column name, games, I don't know, GS. Then just like 3 of the ones that show up here. Then I'll just tell it one other argument, so ascending. So these are just arguments to our function. These are default arguments defined in Pandas Library. If you want to know more about a function, there's 2 things you can do, quick shortcuts. All right, we have one late joiner. All right, cool. There is you can hit shift and then tab and it will bring up this quick short string, which isn't super helpful. or you can hit Shift and Tab twice. There we go. And it will actually give you the entire documentation string for the whole function, right? Which should include what each parameter looks like, a little description of what they do and how to use them, a bunch of documentation about how to use the method, right? What its output should be. So if you know a method kind of, and you're curious what else you can do with it, right? You can always use these quick tooltips to help you. I'm going to use this ascending argument that's built in, and I'm just going to tell it false, right? So we're going to sort descending order, largest to smallest. All right, and then there's a bunch of other ones you could if you want. Axis tells it to go by either X or Y axis. And there's a lot of them. Most Pandas built-in functions have 8 to 12 default parameters like this that you could use, most of which are just kind of niche and you don't need to use all the time. So when I run this, we get back, according to this index column, right, a completely new version of our data frame, right? So all of the rows have been reordered very quickly in memory. So now we sort by this column, then this column, then this column. All right, so it's all sorted adequately and we can kind of look at data in the order we want with the other stuff we don't want towards the bottom. All right. As it may have looked like before, right? Just like our other method we called, this did not overwrite our data frame. All right. It just showed us a copy, which is nice to a point, but ultimately, I would like to overwrite it now that I know this worked. And so rather than reassigning it, right, like I did before, df equals, there's another optional argument here that a lot of Pandas data frame functions have called inPlace, which really is just a true or false that tells it whether to overwrite and do this operation in place, overwrite the existing data frame with the new output. Its default is false so that you don't overwrite stuff by accident, but then I'm going to change it now to inPlace equals true. Because we overwrote, we get no output, but we should know that the next time we go try to look at our data frame, it's in a new order, right? We now have different rows as the last two. Right, and we have different rows as the first two. So everything has changed slightly. So it's a quick way we can sort and re-aggregate our data set and look at it. Excuse me. Another thing we can do, a quick operation we can do, is filtering our data frame, right? Look up stuff from our data frame by certain random queries. All right, and the syntax for this can get a little bit stranger than stuff we've seen already with Python, but it's not too complicated once you get the hang of it. So let's say that instead of my whole data set of 320 rows, right, I instead wanted to take only a subset of it, right? So I'm going to say, I'm going to make a list. I call position list, and I'm just going to put in quickly, let me look up unique values in this column. All right, so we have what looks like an extremely not clean column right off the top of my head. Capital R, capital B, and where is it? Lowercase r, lowercase b are probably the same entry that were just entered by different people or at different times or something and mean the same value. So I'm going to say, let's say, create just a list of all these different aggregates that are probably the same thing. For completion, uppercase R, lowercase b, lowercase r, uppercase b. I don't think those actually existed in here, but I'll use them anyway. All right. So I'm just going to look up all the entries for which the entry in the POS or position column is going to be in this list. All right, and with code, this is very easy. So I'm going to start out with a variable name, right? So that I can access this subset of our data when I'm done filtering and say, cool, equals df dot loc, right? Which is sort of how you can locate your data, all right? The issue is that unlike most functions, right? The functions or methods we've seen in the last hour and 20 minutes have all used parentheses. This uses square brackets instead. More along the lines of this indexing operation we did before to get data by column than a function call. And so the way this syntax works is you just do df.loc and you just put your conditions in between these brackets. All right, and so I'm going to just group these. I'm going to just write one here first, df. So, right, so this gives us, if we walk through this, as we saw up here, this just gives us this column, all right? So this, the entry in this column, dot is in, which is just a method that will return true or false. True if a value in this column is in whatever list or iterable I give it, and false otherwise. So what this is basically saying, this whole syntax is simple, right? Give me all the rows for which this condition is true, all right? So all the rows whose entry for position is in this list, all right? And it's a weird syntax with a lot of parentheses and brackets, but it kind of lets you think like English, right? We want all of the rows where the data frame's position entry is in this list, right? So it's one of these 4 elements, all right? You were showing to us, or do you have a batch file to process lines in many CSV files? I'm going to punt that question to a little bit later because we will actually process a few CSVs slightly at the end. I'm partly going bit by bit to start out with, because once you know the little bit by bits, you can apply them to greater bits of data, if that makes sense. Generally speaking, you have a much larger data. Generally speaking, you have a much larger data source. We're going more on the micro level today, just because that's like the syntax you got to learn. Applying it, honestly, a lot of the time, applying it to a greater data source is more just like indenting it or passing it to a function to do it more dynamically, if that makes sense. If you want, wait to the end or email me afterwards and I can answer that probably more directly. But yeah, right, we're obviously not going to step through this all manually. In practice, the way this process works a lot more in practice is you might do all of this once. And the Jupyter Notebook is frequently used as an environment for like exploratory data analysis. Sort of going through your data and poking around with it and seeing how it's structured, what it looks like. Once you've figured all this stuff out, you can kind of copy paste all those lines of code into a script and just like run it without looking, right? And then just kind of automate the whole process. But you usually need to do this at least once first. You're the part of the process that kind of sucks, just to know exactly what the issues are, exactly what the data looks like and what needs to be done to give a slightly more coherent, longer answer. I will, on purpose, try to aggregate at least most of these CSVs together later to give a quick intro to how we can do that. Again, it's just easier to go micro to macro. But remind me at like 7:50 just to make sure. Anyway, so we've got this, right? This was a single condition. We could alternatively, right, with pandas, we can use the ampersand, right, the and sign to chain conditions together. So I could say and df, you know, some other numerical column greater than 11. Rerun this, right? Now we'll get all the entries for which both conditions are true. And we can keep filtering and refining our data until we have what we want. Let's run this one more time. Whoops, I don't know what I did. hit some weird key. There we go. RB underscore list. No, I think I made a text cell with some weird shortcut that I hit by accident. There we go. And so now we get no rows of data. That's not good. I'll get rid of the second condition, which may just not exist in the data. Yeah, I guess that one just didn't exist in the data perfectly, or had like some weird syntactical issue. Either way, we now have 61 rows, right? So we're able to filter our data from that one condition down to 61 rows we hypothetically wanted. Right, and we can kind of, if we want, continue on here, either looking at it or just take a quick length of a list, right? 61 elements. Cool. Again, you can really chain together as many conditions here as you want within reason. For complex filtering, you can approach things you might be able to do with like SQL or other data languages if you really want to. Advanced queries, you probably won't get too advanced because the syntax is just kind of weird and hard to follow, but you can get pretty close. Cool. So the next thing, right, is we have all this, but we can also, if we want to, create a new column. The way you can do that is actually super simple, which again, begs the question of to be careful. Make sure you know what you're doing, all right? So you could say, for example, df, right? Let's just say, yeah, let's just go with YDS %, right? Which is just going to be a relationship, right? The difference between everyone's entry in this aggregate, right, yards column, and the maximum, right? So what percentage of the maximum did you get in this column? The way you create a new column is simple. You just say df column name equals, right, and then some expression, and it will actually compute that expression for every row if you want. So here I'm going to say df YDS divided by 1364. I'm going to wrap this in the round function so that we don't get something that's hard to look at. I'm going to put it in two places. And it ran very quickly. We don't get an output again, but if I rerun this, df.head, we can see, in fact, that we now have this new column with the name I gave it, right, using an underscore so that I can use a dot if I want to. And all of these values have been computed correctly, right, numerically. These have all basically been, whatever, these all look basically right to me, right? For now, just using the eye test to look at our data, but you can dynamically create columns with relationships between columns that easily, right? We could replace this hard-coded number with, some other column if we wanted, right? Or, for example, we could have done df like games missed equals, and then use, games equals, let's see, 16 minus df gs, right? Whoops, with square brackets. Right, and again, this is, me knowing the data more than anything else, but it's another, I ordered by this column, so it's going to give me zeros. But you can keep just throwing in aggregate columns like this as you need to if it's a little bit easier. You could also always keep things like this into analytical code and not add it to your data instead. That's up to you. But that's up to you. It's at this point we've manipulated our data a bunch of times that I will stop and note that if I refresh this page, our CSV has not changed yet. All right, we don't have any new columns. We don't have anything else. This is all actually still in memory. So when I say we don't want to mess up our data, when we do these operations either in place or without overwriting our original data, I really just mean you don't want to overwrite it in memory and then have to close and like rerun the code in your notebook to reopen the file, reprocess it. All right. But this data will never be overwritten on disk until we actually like manually call a function to save it. So it's important to know and understand that, to know that you have a pretty free environment here to play around with your data, not mess up the persistent data on disk you have, which is usually a nice license to have, especially for learning. Just don't call a function to save it unless you know what you're doing. So while we're here, we're going to take some of these Python ideas we've learned and put them together to process some of our data, right? And again, I'm going to move this back to 2 so it's smaller and move this cell down a little bit so we can see it. When I use a notebook, I usually have something like this chilling near what I'm writing at all times, just because it's easy to have a nice snapshot of seeing my data as I do stuff to it. But I'm going to say, let's take this name column, which is not called name, but it's what it is. And actually process it so it's really just a name. All right. And before we do that, I am going to get rid of this RK column, because now that we've sorted, our numerical rank is kind of meaningless. So I'm going to use this df.drop function, which, if we don't remember how to use it, right, you can just open up the tooltip, see what it does. Ultimately, it will simply remove rows or columns. Generally speaking, it's obviously a bad practice to drop many rows from your data, right? Usually rows, even the ones you don't like, are meaningful and important bits of your data. I'm going to use this instead to clean up columns I don't need, all right? Which can be a nice, tool to have in your back pocket, specifically for columns like this, what we actually don't want. There's a bunch of ways to do it, right? You can give it all kinds of arguments here. Excuse me. For now, I am just going to give it like it does here, right? You can just give it, which is just good to get in the practice of looking at. I'm just going to give it columns, right? And we'll get rid of said columns. Again, documentation can be challenging to read, but it's a good idea to occasionally look at it if you're curious, because it is your most helpful tool when you're not in a webinar or when you're on your own trying to learn this, right? Is to look up, all right, how do I use this function, right? How do I drop a column using pandas? All right, so I'm just going to give it df.drop, give it a list, but I'm going to give it just for now RK, and none of the other ones seem to matter. Axis equals 1. Just like that, gives us this new output that has no RK column in it. Obviously, right, if we have gotten kind of used to the way pandas works, it doesn't do it in place unless you're explicit. So now added in place equals true, and now it's gone, which, at least I wanted, right? So we have that meaningless column gone. We have a little bit easier data to work with. I could drop most of these columns. We're not going to use most of them today, so it's fine, but I'll keep them for now. So now that we have our data with that column missing, let's think of this. And if anyone in the next 45 seconds can put in the chat, trying to make this slightly interactive. Again, usually I give this in person and it's much more interactive workshop. Can anybody think quickly of how we might clean up these names? What seems to be the pattern through which all these names are messed up? Nobody has chatted it yet. There seems to be a pattern. I will give you 30 more seconds and 7 rows. Somebody said the slash, yes, technically it's a backslash, not a forward slash, but yeah, backslash. Specifically related to the backslash, right? If we think of the kind of algorithmic way to go through processing this, we've got a backslash for every name. It is indented. I'm going to make this string called test. Technically, we want everything to the left of the backslash, right? It's kind of the ultimate goal. We want to get everything to the left of the backslash, and I'm going to use this name instead. And as an added bonus, occasionally, and for those of you seeing this, this column is just not given enough room. There is technically a space between first and last name, like it is presented here. So for space last, it just indents because it doesn't want to give the column like too much room. And there's sometimes these, right? Asterisks. There are, I believe, also plus signs occasionally, which I believe are related to footnotes on the original website. But ultimately, we want everything to the left of a backslash. And then sometimes we also want to get rid of extraneous punctuation. Does that seem fair to say? All right, someone gave me a nod over video. Otherwise, I will let you guys write true or yes if you want. But that is sort of the algorithmic way to approach this. And part of what I'm trying to get at in this webinar is that even with code, right, there is not really a silver bullet for like figuring these problems out at some point with your data. We can just apply them to very large data sets very quickly with code. It doesn't take the annoying cleaning, like thinking about cleaning task away from you. It just lets you apply that quickly once you're done. For now, rather than try to iterate through our whole data frame, I'm going to make a quick Python function, all right, which I usually make y'all help me with, but we can't really do that in a remote capacity as easily with the chat, because getting people to chat's kind of like pulling teeth. No offense, folks. So instead, I'll just kind of walk us through it. So here's the procedure, right? We're going to first get rid of this, or get rid of everything to the right of this and then get rid of punctuation. So I'm going to define a function. For now, I'm going to call it name clean. We're going to take in as an argument a name, which will be a string like this. And now I'm going to say for now, if this function works for this test name, it should be good. Well, I know it'll be good, but it should be good for our uses later. All right, but I'm going to create this little testing area right here, so I don't have to do this through my whole data set, right? This should process fast enough, I don't care. If I had like 350,000 entries, obviously that would just be a waste of my time. So I'm going to take in a name, and I'm just going to say, cool, new name equals, so I'm taking in the old name, name dot split. So split, and I'm going to walk through all these as we go. Apologies to those of you who've seen Python before a little bit. Split is a very simple Python function, or string method, that will by default convert a string into a list of substrings. Does anyone notice what we used to make the substrings? 15 seconds. And there's an English language equivalent to what we just did technically. We took a sentence, as I wrote here, right? And we turned it into words, which really means we looked for spaces. We turned this string into a list of words separated by spaces, all right? It works like that by default. Alternatively, it will happily take in any argument you give it and split based on that. So if I jump in here and say, yeah, let's split it based on the character S, it will do that. And instead I get this random garbage, right? This I and then A. Well, technically space A, right? The spaces are preserved now. And then, ends, right? We can use this to our advantage. because we can use indexing, right, which is how you can access an element positionally from a list to get, let's say, first element here, right? So we can use this whole behavior to our advantage and simply say, let's split the name into 2 words, right, using a backslash, and then just take the thing on the left of the list, right, the first element of our list. So for example, if I say test dot split and give us a backslash, technically in Python, the backslash is also used as an escape character. If you notice, right, this is still red, this is still a string. Backslash is usually used as an escape character, which lets you, for example, include a quote in strings. So this is not the end of a string, this is the double quote character. I added a second backslash. This made my string terminate. It's really, in a weird way, it tells the backslash to escape the other backslash and treat it as a backslash character, which is a strange but it's just the way it is in Python. It's kind of what we need to do, right? Ultimately, test.split double backslash gives us, didn't rerun that. There we go. This, right? Thing we want, garbage. All right. And so we can either assign this and then do this, or we can, in one operation, say, let's get the first element from our list, which is going to be element 0. Indexing positionally with numbers is the same as we did it by column before. So we can just say test.split backslash element 0, or first element, right? Because it's all 0 indexed as we saw earlier. Make it the first letter. Cool. So I figured out the first step. The next step is going to be to get rid of punctuation. And as far as I know, it's just asterisks and plus signs. And in all the time of using this data in this workshop, I have not found other punctuation shown up. So I'm going to assume that's it. So I'm going to return finally new name dot. So I'm going to call this test2 equals. Cool. So we have this. We want to get rid of this punctuation. I'm going to use another Python string method called strip, which takes a bunch of arguments and will get rid of all of these from the beginning or end of a string, but not the interior. And that is important. So if I give us an n, our string is unchanged. If I put in, I put 8 n's at the end of our string, rerun this, right? We still have these here. If I use n, we get only the n's at the very end of the string, all right? Which is, again, very important. Because, right, some players have punctuation in their names. I don't want to, whoops, we'll ignore that for now. I don't want to get rid of that punctuation. I just want to get rid of the stuff at the end of the pseudo names we have. So I'm just going to give it asterisk and plus. It's a good use case for the strip method here. So I end up with this name, Steven Jackson, right? Which is no asterisk, basically what I want. So I'm going to return new name dot strip. Asterisk plus sign, a lot of backslash just in case. Why not? In case there's 2. All right. Cool. I'm going to now move this up here. And instead, I'm just going to call name clean with its actual name with our test and make sure it gives me the right result, right? And I got an error, empty separator. Name.split that 0. All right, I forgot to give this. There we go. Cool. We get back our clean output. So I'm going to say our function's ready to go. Again, this is a usual process, right? Going from the micro, like, does this function work, to let's apply it to the whole thing now, all right? So the way we can apply something programmatically to our whole data set, I will switch this to 2. Move this cell on down again. Cool. is with a data frame method called apply. So df.apply, and we're going to just say, let's see. So apply is going to take in our function as an argument, so name split x equals 1. I'm going to see if I can do this without the complicated syntax I have in my notes, because it's a lot harder to see. So a function, the axis, which is just going to be going by row instead of column. Oh, name clean. And all right, fair. I'll use the complicated syntax then. Excuse me. So df.apply. I will instead use a Python lambda. Lambda is a way to quickly declare an anonymous function. So lambda, before I use it, I'll introduce it real quickly. So this is a quick Python way. You can define a function with no name. It's usually used as an argument to other functions like this, which we're going to have to do now. This is just a quick function that takes x as an argument, returns u x plus 2. It's just a quick abbreviated syntax, very popular in data science and analytical computing especially, where you do a lot of stuff like this. So I'm just going to say lambda row. So we'll take each row as an argument, and we're going to call name clean on each row, row's value for unnamed colon space 1 with 2 n's. So this is a long form way of saying we're going to take each row as an argument, pass each row's value in this column to our function, right? Each name from this column, and it will apply this to every row. And I forgot, close parenthesis. Apologies, most, oh, and I probably spelled it wrong again. Lambda row, name clean. I will just copy this from my notes then. Oh, all right, fair. So I'll just copy this from my notes in the interest of time, because I have some slight syntax error. Name clean. Cool. It was probably a parenthesis, colon, something stupid. Apologies, it's part of code. Ultimately, I reassigned it, and now our whole column has been cleaned. All right, so all the names look nice. And it's programmatically, I'm going to assume it worked for, right, the whole data frame. I can't know for certain, but I know it was all messed up the same way, and I'm relatively certain. Quickly, I'm going to quickly reset our index now, overwrite this, just make this name column our index. So I'm going to say index df.set index. This will just take a new column, make it our index instead. I'm just going to say that looking up by positional number from when we opened the data makes no sense. Instead, it works to do it by name, just for the data in particular. I'm going to use unnamed colon space 1, spelled correctly, I think. In place equals true. Cool. Now it's bold. And then I'm going to df.index.rename. Another function that will literally just take the index, rename it, whatever string you give it. I'm going to call it name. I'm just going to say in place equals true here, too, just because I know it's the correct syntax. And if it's wrong, I can just rename it real quick. And our data has been cleaned a little bit, right? Obviously, we did this at a micro level, but once we know this all works, we can use things like the apply method, like something else, right, to walk through all of this and process data on a much larger aggregate scale. We could do the same thing with catch percent, right? Take in a string and say def update catch C underscore PCT. And we could just make a function that, for example, returns like C underscore PCT dot strip, right? Get rid of the %, then wrap this in a call of the float function in Python, which will just turn a string into a float if it's presented as numbers with a decimal point. All right, so hopefully this makes a little bit of sense, but this is an alternative way we could process our data, clean it up a little bit. All right, if we wanted to continue on cleaning and processing. Real quickly, I'm gonna pause in the next few minutes to make sure I get through this, just to show quickly the plotting functionality and how that shows up in a Jupyter Notebook, because that's great to know, usually relatively interesting to people, and honestly, it's just interesting. All right, so I'm gonna quickly say, all right, what if I wanted to look at some trends in my data really quickly, right? Say I have more than 300 lines, right? I have 1,000, and I wanna graph some columns against each other, right? Matplotlib, this is pretty easy. I can just use plt dot, usually chart name, right? I'm gonna use a scatter plot, plt dot scatter. And I'm gonna go with, let's see, our age column, because this should probably show a trend, and df yards, why not, right? And this one line of code will generate a quick chart. Age is our x-axis, yards is our y-axis. Takes a second, right? And it will just plot all of our chart data out for us in line in the Jupyter Notebook by default with like blue and white, right? Just so we can look at it, see if we see any quick data jumping out to us, right? Is it, seems right, athletes get worse as they get older. No shocker there, but you can kind of see a distinct trend line, which is nice to know. Optionally with Matplotlib, there are a bunch of different ways we can slightly edit it. We can go with, an X label, right? Where we can say, just pass in an argument. So age, Y label, yards, plt dot title. Webinar sample chart, and then it will, you can just, there's a ton of different configurations you can use to make your chart a little bit nicer, change color, shape, size, whatever. But also of note, there is a cool plt.save figure function that just takes a file name. We'll save this to webinar chart.png. We'll actually save it to a persistent file as well. If I give it a second, hopefully it updated by now, right? It has shown up down here. If I open it up, we now have a statically saved chart image. It's not amazing, but it could be good to have or keep for later. If we want to, I'm going to copy some code for time's sake, just to show you that this exists, right? We could create, bar charts alternatively. This is a series of 5 integers and a missing NaN value. This is just an example of some of the random functionality that exists in Pandas. This is just a date range generator. It'll just generate you a bunch of, have a periods number of dates from a start. This says 2019, March 4, I'm gonna give it 2020, April 29th. So 6 periods from today. Can be very helpful for like labeling time series data, something like that. So we're seeing into the future now with our bar chart, I guess. Mostly just to make sure that we have, that you guys, if you want it, have some reference code for this. We can also create a bar chart, same way with plt.bar, right, x, comma, y. And we'll get something like this. The x values aren't perfect right now. You can always reformat those. But we get something like this, all right? Which is cool to see. Hopefully, right? You can aggregate data at large scale into little images very quickly. Obviously, we won't cover everything today, If anyone wants to stay on for an extra few minutes, I will address that question about at slightly larger scale in a second. Show at least one way we can use Python to start aggregating data at a larger scale, right? This isn't even the largest scale I had available in my folder. I have CSVs from 2018 to 2000, right? So I have at least 19 times the data we worked with just hanging out here, and this complete one that is an aggregate of all of them. So let's aggregate some data, all right? So like I've done the whole time, I'm gonna preface this with a built-in bit of Python functionality just to do it. Part of solving all these problems is always sitting here and thinking through, all right, how can I programmatically solve a problem, right? Just like we did with the names, right? If you haven't written code before, again, target audience, apologies to those who have. If you haven't written code before, right, that can be a weird thing to do, but like you did with the name, we sat down and said, all right, these names are all messed up. Every name, we need to take that backslash, take the thing to the left of it, get rid of the punctuation after that output, and then we're good to go. All right, and the same thing is really true here from a different perspective. So I'm gonna say, all right, I know this about strings. I technically know that in a Python string, we can actually manipulate them dynamically. If you put brackets in a string, two syntaxes for this, I'll use the older one first. There's a string format method that will take an argument, and we'll take whatever its argument is and put it in the place of whatever curly braces exist in the string. So when I print this, I actually get the string. This is a string, right? Finds the curly braces, says, all right, cool, this goes there. You can do it with multiple arguments too, right? If I run this, we get it backwards, but you can even use positional arguments, right? This is element 0, this is element 1 now, so this should be, whoops, backwards. This is element 1, this is element 0. Now it is element 0, right? So it will be the same way. There is another Python syntax for this in more modern times, which is an F string. So technically, you can also preface your string with an F and then pass variables in. So if I said, input's a built-in Python function, string equals string, right? I could always type in new string here. And this will work the same way. It just doesn't need the format and the parentheses. It just gets a quick F before the string. You can pass variables in, kind of like the JavaScript type of template string. The point here is that I know I can do this, which means that I can programmatically, if you looked at these files, it's not rocket science. They start at 2000. They go to 2018. I can programmatically generate my file names by just adding characters to the end of the stem 20, right? 00, 01, 0, whatever, et cetera, et cetera, et cetera. All right. With the caveat that 2000 is going to be a little bit challenging numerically. All right. Is the audio back? Cool. So I know that I can programmatically generate these file names if I'm a little bit careful with my strings, right? Starting with 20 and going from 00 all the way to 10 or really 18, all right? Which is going to be a little bit tricky because using 0 as a character is going to be a little bit interesting, but we'll do this in an easy, naive way to start out with. So I'm going to start out with this. I'm going to say stem equals 200. Now I'm going to programmatically generate a list of data frames that I can actually process if I want to, right? So I'm going to just make a giant aggregate of all of my data. All right, so I'm going to start with this and say, cool. like we did before, for I in, and I'm going to use this range generator in Python, which basically just says, whoops, there we go. Which basically takes a start and a stop non-inclusively and will iterate through all of those numbers. So we'll go 0 through, no problem, Joshua. You'll get a follow-up email afterwards as well with links. 0 through, I think it was 10. So I'm going to start with 10, right? We're going to create a bunch of data frames. So I'm going to say, cool. Here's our stem. And I'm going to say dflist.append. Append being the Python method to add to a list. So read CSV stem.format I. So this is a little bit more complicated code, obviously, but the whole premise here is this, right? If I think through how to tackle this problem, I can create a data frame from all of my CSVs from 2000 to 2009. All right, again, range is not inclusive of the last number, which is good because I don't want 20010 because that year hasn't happened for a long time or won't happen for a long time. I'm just gonna, for now, print df list, right? And I had one error, stem.format I. File 2000 does not exist because I forgot the .csv. Always got to be perfect with the programmatic stuff. There we go. Right, and we get this. It presents itself and prints really weirdly, obviously, but the gist here is that we got all of these data frames that have 300 something rows and 28 columns. All right. Ultimately, what I want is the length of our data frame list. It's 10. Cool. And so I'm just going to do this really quickly again. And rather than stem, I'll just use a hard-coded string. So I'm going to use 2o this and use 10 to 19, right? Again, the reason I do this in 2 steps is because if we're programmatically creating integers, I'm never going to get like 01 or 04, right? So I can't get 2004 off of 20. Does that idea kind of make sense to you guys? All right, the one person with video nodded, so I'm going to say yes, cool. So now, barring a catastrophe, it ends at 18. Maybe I missed it, and 2010 doesn't exist. Apologies, same issue, .csv. Cool, and now I have 19 different data frames together. All right, so I've taken all of these data frames. I have 19 in a list, and now I'm gonna get rid of this print for now, and I'm just gonna run this. So when I run this, our df_list variable is still a list of 19 data frames. All right, so now that I know that worked, and they're all in the same format, I can aggregate them all together. All right, so I'm gonna just quickly say full df equals pd dot. And the last method we're going to go through today is just the concat method, which will take however many data frames or an iterable, a list of data frames that I give it, and concatenate them all together, right? Assuming they have the same structure. Big assumption, but I got them from the same source and just know they have the same structure. df list. And I'm going to also tell it ignore index. Oops, equals true. So we'll ignore the index columns for each one of these guys for now, and we'll preserve each of the original indices. So I'm not going to get like rows 0 through 5,000. All right, so concat, to repeat, just takes 2 things. It will concatenate a bunch of data frames. Think vertically, right? Assuming they all have the same columns, so that instead of 19 data frames, we're going to have one data frame of 19 times each one's number of rows. right? So we're basically going to take the years, I mean, you know, functionally in terms of this data, we'll take the years 2000 through 2018 and add all of that data together in one place, right? So I should get, no errors is a good sign, so I should get here 5,917 rows, all right, which is the aggregate of all of these together. And I'll add one more column, right? Full df. We'll just look at it real quick, right? So we have all of these columns in the same format, but now we've just added the rows from each subsequent data frame onto the top one, just like inserting new rows of data. All right, starting from the oldest, going down to the most recent or last row of our last data frame, the one that was 2018.csv. All right. So this isn't like a perfect intro to how you can start doing stuff at scale, obviously, but it's a quick intro at least, right? From at least theoretically no coding to where we are now of like, we can take all of the data we had, right, and start at least programmatically building larger and larger data sets, right? And taking the coding concepts we went through and applying them to problems like that, right? Now that we can solve these micro problems, we can say, all right, we can generate all of our data frames, all of our things, right? Now we can apply functions to filter all of these names, right? Filter all of this column, right? Add new columns, aggregate our data, etc. Once that works, we could always write a script to do it programmatically outside of a notebook with just like a click or a terminal command or something. All right, we can't get to that today, obviously. That would be a huge ask, especially asking everyone to use their terminals is usually a huge ask. But I hope this was at least somewhat informative for y'all as well. Again, I'll send you guys a follow-up email with a link to a recording of this webinar and the data frame I used today. I will probably send you my notes data frame anyway, because why not? You might as well have it. And all of the CSVs I used, as well as, there's at least one other thing, documentation for Pandas, NumPy, Matplotlib, Jupyter. Probably a plug for my other free webinar a week from today on the basics of writing Python code and more like the beginning, right? Data types, functions, stuff like that. And that might be it. Otherwise, if anyone has any questions about this stuff, Python, coding in general, not related to Python, learning it, places to learn it, resources. I get these questions all the time. Happy to help. My email is, I will put it in the chat right now. It's, fortunately, my name is super boring, so it's easy. That's my email. I'll send that in the follow-up as well. Feel free to ask me questions about Byte Academy, our courses. We have courses starting soon for beginners, intro, or even a few short courses on like building a web app or intro to a data science project. Both of them are like a week long and should be relatively quick and informative. I'll send links and details to those if I remember those 8th and 9th links to my email. Questions about that, let me know as well. I can answer whatever, pretty much it being my job. Otherwise, thank you guys for joining, toughing it out through the entire quick 2 hours, you know, listening, coming here, spending your Wednesday here. Stay safe, certainly. Otherwise, thank you all for showing up. No problem. Thank you guys. Again, let me know if you have questions. Expect the email in like maybe an hour, maybe more, maybe tomorrow morning if it takes a while for the recording.